Hey guys, this video is going to be about my project that I've been working on this past winter break, the hand crank generator. So recently I got a 3D printer and I love physics, so I wanted to combine those two concepts and work on a project. The main idea behind this project is the Faraday's Law, discovered by Michael Faraday. This law is mainly about how a change in magnetic field creates an electromotive force. You can think of this as a force that pushes electrons, which generates current in a copper coil, in a closed circuit, of course. Before I get into the design process, I wanted to get familiar with the concepts that actually allowed this project to work. And so after a lot of research, I stumbled across this simulation depicting how a constant stream of water spins a turbine with a magnet inside at 100 rotations per minute, which generates a current in a coil that's close in proximity, and the light bulb is being lit. So the main facts I want to list over here are that you can see that there's a change in magnetic field by the compass over there, and as represented by the blue dots in the coil, the electrons are being pushed or moved by the electromotive force or EMF created by the changing magnetic field. An interesting fact here would be that this creates a AC current, so alternative current. That means the electrons are moving in two directions. Like shown here, it's moving up and down. The opposite of this would be DC, direct current, where the electrons are going to be only moving in one direction. That will apply to this project later on. Now, looking into the design, I used Fusion 360, which is a CAD software, and modeled my project up to scale so that I could simulate and visualize the interactions between the mechanisms on the model. So the main mechanism I used was the beveled gears in order to transmit motion, rotational motion, in 90 degrees. So if I rotate the smaller beveled gear to the right, the larger one would also rotate to the right, but it's still perpendicular so that it would still transmit rotational motion while changing the direction. And then I created a stand which I can put the coil. But before I got into actually printing the whole thing, I made a prototype of just the big beveled gear, sliced it up using Ultimaker Cura, and 3D printed it out so that I could test if spinning this mechanism with magnets on could actually work. But the result was there was no output. What I did was connect the coils to a 4-diode rectifier, which converted the AC output produced by the spinning coil or the spinning magnets into a direct current into a light bulb. But I realized that the current produced or the output of the spinning magnets may be too small or not big enough to light the light bulb. So I just decided to go ahead and print out my whole design. I laid out my whole model, took apart the individual parts, spread them apart so that the printer can individually print them without any problems, converted it into a .stl file and exported it to Ultimaker Cura and sliced it to see how long it would take, and it would take a day and 2 hours. After a whole day and almost 500 grams of filament, my final product is ready. But before that, let's compare my 3D model to my actual one. Here's the 3D model, And here's the actual model. So looking at the joints are working as they're supposed to. There is a little bit of friction, but it is satisfactory and will allow me to get effective data on the output of this generator. So yeah, we have one last step, which is testing. Okay, I have my generator hooked up to the Astro AI multimeter to measure the AC output of the voltage when I spin this mechanism. But on the side note, I just want to share this cool thing I made. This is a 4-diode rectifier, as shown in diagram earlier. What it does is it converts AC currents and redirects them into a DC current, where no matter what side of the battery you put on these wires, the current ends up always being where there's a negative side, that's a positive side, so the electrons always go that way. So it's pretty interesting if you have 4 diodes and you can make it at home. Okay, back to the experiment, back to the testing. What we were trying to test is if the output voltage increases, so if this number increases if I spin this. So let's find out. Okay, definitely increases. It went up till 235 millivolts. So we know it works for sure, but it's in the units are millivolts. It's really small, which explains why the light bulb didn't light up earlier. Light bulbs like this one, if I get this into focus, light bulbs like this one require at least 1.5 volts in order to light up. But 200 millivolts is not enough to light it up, which explains why the light bulb previously didn't light up. So now we have to find a way where we can increase the output voltage so that we can power day-to-day items like cell phones or even this light bulb. As you saw from the testing, the output voltage of this generator is not too high. It wasn't even high enough to power this bulb, which is just 1.5 volts. So this still needs upgrades. I do have some in mind though. So the first one would be to just add a gearbox where rather than rotating this shaft directly with my hand, which is pretty slow, I would put a gearbox, rotate the input shaft of the gearbox, and make gears such that the output shaft speed would be larger than what I'm spinning this at. So I would spin the gearbox once, the output shaft would spin, let's just say 50 times roughly. And so if I connect that output shaft of the gearbox to the input right here, this would spin much faster when I spin the gearbox. Again, this is just prototype 1. This was just introducing me to the concept of Faraday's Law, how it works. There's still a lot of math on how I can calculate roughly estimate how much voltage can be generated, and just how this generally works, but mathematically. I plan to do that when I get to learn more about this topic in my AP Physics class at school, and when I actually build the gearbox and test the gearbox with this prototype. Thank you so much for watching, and see you later. Thank you, Radicubs Robotics, for letting me use your calipers.